is momentum. In this lesson, we shall learn how to describe momentum, and we shall also carry out some calculations involving momentum. Momentum is a common term in our everyday speech. For example, if a car starts rolling down a hill, we would say that the car is gaining momentum as the car speeds up down the hill. If we were to stop a moving object, there are two factors that dictate whether it is easy or difficult to stop the object. And these two factors are: 1. The mass of the moving object. In this, we could say that it is easier to stop a smaller object that has a lesser mass as opposed to stopping a very big object having a bigger mass. For example, it is easy to stop a table tennis ball than to stop a cannonball, because a cannonball has a bigger mass. The factor number 2 is velocity at which the object is moving at. If an object is moving slowly, it is easier to stop it. But if it is moving very fast, it becomes increasingly difficult to stop that moving object. So combining the two terms, we would say that momentum is a measure of how difficult it is to stop a moving object. Then mathematically, we can express momentum as momentum equals to mass times velocity, which is a very important formula in calculation of momentum. This can also be written using the symbols, and that is P equals to M times V, whereby P is the momentum, M is the mass, and V is the velocity. So, what is the SI unit of momentum? From the definition, we have momentum equals to mass times velocity, and we know the SI unit of mass is kilograms, then the SI unit of velocity is meters per second. So if we combine the units of mass and velocity, we would have the SI unit of momentum being kilogram meters per second. Calculations. First question: determine the momentum of a ball of mass 200 grams traveling at a velocity of 30 meters per second. Solution. First of all, we need to convert 200 grams to kilograms, and we do this by dividing by 1,000. So 200 divided by 1,000 is 0.2 kilograms. Then we know that momentum equals to mass times velocity. So we now substitute for the mass and velocity. So we have 0.2, that is the mass, in kilograms multiplied by 30 meters per second. This gives us 6 kilogram meters per second, which is our answer. Question 2. A bullet of mass 0.02 kilograms is fired from a gun. It moves at 900 meters per second towards the target. What is the momentum of the bullet? Solution. So we write what we know first, and that is the formula or the equation. Momentum equals to mass times velocity. So substitute for mass and velocity, and that is 0.02 kilograms times 900 meters per second. This will give us 18 kilogram meters per second as the momentum of the bullet. Question 3. A rocket of mass 1,200 kilograms is traveling in space. If it has a momentum of 1,800,000 kilogram meters per second, at what velocity is it traveling? Solution. What we know is momentum equals to mass times velocity. So we substitute for what we have, and that is momentum and mass. So we have 1,800,000 kilogram meters per second equals to 1,200 kilograms times the velocity that we are looking for. So it means that velocity equals to 1,800,000 divided by 1,200. Therefore, this is equal to 1,500 meters per second. So that is the velocity at which the rocket is traveling. It's now your turn to practice with a question. Determine the momentum of a tennis ball of mass 55 grams traveling at a velocity of 20 meters per second. Please don't forget to subscribe if you have not yet subscribed. I look forward to seeing you soon. Goodbye.